All right, let's look at some rational expressions. We see that we have numbers and variables, and in the top example we have an x and a y, two different kinds of variables. Same thing down here, and I like to split them up because the way we look at numbers under a radical is a little different than the way that we look at a variable under a radical. And with these, you're both going to notice that we have something outside of the radical. Okay, and that shouldn't change anything. It's just going to stay there. So the example on the top, we have negative square root of 81x to the 8th 20. And I'm going to split it up. Square root of 81, square root of x to the 8th, square root of y to the 20th. And we can only do that if there are no pluses or minuses in here. These are multiplied. So, square root of 81 is just 9. The square root of x to the 8th is just x to the 4th. And then the square root of y to the 20th is y to the 10th. Okay, so we got lucky. Nothing left under the radical. All of our radicals are gone. And then our answer is just going to be negative 9, x to the 4th, y to the 10th. Okay, now the problem down here, we have negative 5, square root of 4x to the 6th. I'm going to split this up, drop down the negative 5, and I'm going to put the number under one radical, square root of 4, and I'm going to put the variable under another radical, square root of x to the 6th. Now let's simplify these radicals. Do I know the square root of 4? Yes, of course. The square root of 4 is 2. And do I know the square root of x to the 6th? Yes, I do. How many groups of 2 can I take out? And the answer is 3. So once again, nothing is left under the radicals. And then I will put these together. I have negative 5 times 2 is negative 10. X to the 3rd.